Good morning students. Today we will discuss about a device that is meter bridge. Meter bridge is a device which is based on the principle of Wheatstone's bridge. With the help of this device, the resistance or specific resistance of material of a given wire can be determined. Yesterday we have studied about Wheatstone's bridge principle. P by Q was equal to R by S. So if a resistance value is still unknown, you will be able to use this equation to calculate the value of unknown resistance. P by Q equals R by S. Here we are applying the equation. We are applying the principle of Wheatstone's bridge in the device meter bridge. So meter bridge will help you to calculate the value of unknown resistance of a given wire, of a given material, anything, etc, etc. So in this device there is a 1 meter long wire like this. So this one is having 1 meter total length that is being connected between the points A as well as the point C. From the point A there is a resistance box is being connected. So this resistance box is non-resistance. Okay, non-resistance. When you come to physics lab, I will show you what is resistance box. Anyways, this resistance box is still known to you, that is known value of resistance, maybe 2 ohm, 6 ohm, 10 ohm, maybe thousands ohm, it may be according to our values. And this one again I am connecting a resistance wire here. So this resistance wire is the unknown resistance value. Here you can connect anything in the sense, this pen cap you can connect a wire, a refiller, a paper piece, a wooden piece, anything you can connect which is conducting. That means that resistance value, it is unknown to you. You are going to calculate the resistance value of that particular wire. So I am connecting a known resistance value here and I am connecting an unknown resistance value also here. So P by Q equals R by S. Let it be R and let it be S. So P and Q also we have to calculate. From where we will get that P and Q non-resistance value? That is the next question. So from this middle portion, I am connecting a galvanometer G, and from that galvanometer G, I am connecting a pointing device like a pen. That pointing device name is called jockey. This pointing device jockey is being connected or being touching to this wire itself. So when we are touching to that wire, in the galvanometer there will be so many values. Galvanometer is being used to calculate, to find out the presence of electric current. So how much is the value of electric current? You will be able to get it easily. So yesterday we have studied what is the balancing condition of Wheatstone's bridge. Balancing condition of Wheatstone's bridge is Ig current should be equal to 0. That means if the galvanometer is showing 0 deflection, balancing length is being applied, or the Wheatstone's bridge is being balanced. When this wire is connecting at the correct area, this jockey is touching at the correct area anywhere at this 1 meter length wire, when this jockey is being touched, then this galvanometer will once show this 0 value. Then at that position you will be able to calculate the density. Say now if the galvanometer is showing 0 ampere, that means it may be 70 centimeter and the remaining length may be 30 centimeter. Out of 100 centimeters, up to this distance from A to this position it is 70 centimeter, and from there it is 30 centimeter. That means 100 minus 70 will give you this distance, correct? So 70 and 30, that can be taken as the P and Q values. So this distance or this length is being taken as the P and Q value. So this one is known to you. When we are touching and getting this galvanometer 0 deflection value, this one length also it is known for you. That one I will take it as P, and this one also is known for you. 100 minus this much length, that is also known for you. This is how we are calculating the value of unknown resistance S. So now I am saying the exact procedure here to find out the unknown resistance, that is S, or specific resistance or resistivity also you can find, of a given wire. With the help of this device, with the help of meter bridge, the electric circuit should be made like this, and this point A should be connected to a cell like this or a battery like this, plus as well as minus. So this cell is providing an EMF E to this circuit. So for this purpose, a cell E and plug K. So a plug also you can connect. Plug means a switch. Switch can be called as a key in physics. So a key K also is fitted between the points A as well as C. A galvanometer G and a jockey between the points A as well as C is being connected in this device. The null deflection or the 0 deflection is obtained by rubbing this jockey along this wire. When I am rubbing or when I am moving this jockey along this wire, I will get at one point the galvanometer reading as 0. That length position I will take as the balancing length of the meter bridge. When I am, suppose this is the jockey is just similar to a pen. When I am moving this jockey over this wire, at a particular point the galvanometer will show 0 current, that means 0 deflection. Ig current becomes 0, that is the condition of Wheatstone's bridge. So that length is, that particular length from A is the balancing length of this meter bridge. Okay. So now look here students, A and C, in between there is a jockey. I told you galvanometer will show a 0 deflection when I am rubbing this jockey at a particular point. When this jockey is being placed over at a particular point, this galvanometer will show you 0 value. That point I need. So suppose at this point galvanometer is showing 0 deflection as I told before. So this point I am naming it as B. Okay, so A, B, C. How much is this AB value? I am taking this AB value as the balancing length of this meter bridge. What is the balancing length? Balancing length means Ig current is showing 0 value, 0 ampere. There is no deflection in galvanometer. So AB is the balancing length. I am taking it as L. Okay, so what is this BC? BC means the total distance is 100 and out of that 100, L distance already I have taken, so the next distance is 100 minus L. Everything is in centimeter also, that you can write L centimeter as well as 100 minus L centimeter. Yesterday we have studied the Wheatstone's bridge principle. P by Q was equal to R by S. P by Q was equal to R by S. Now I have my R value here. R means non-resistance, and I have my S value, that means unknown resistance also here. Now P and Q I have to take. Now I am substituting this AB as my P and this BC as my Q value. Okay, so P it is L and Q it is 100 minus L. And what is this R? It is my known value. It is known to you, maybe 2 ohm, 6 ohm, 10 ohm, it is known to you, and yes, I don't know. So from this equation you can substitute P, instead of P you can substitute L, and instead of Q you can substitute 100 minus L, and instead of R it is known for you, so R it is known, and S I don't know. So you have to calculate the value of S from this equation. S will be equal to 100 R into 100 minus L whole divided by L. This will be the answer. S will be equal to R into 100 minus L whole divided by L, where L is the balancing length. Again I am saying, when I am rubbing this, when I am moving this jockey over the wire, at a particular point this galvanometer will show 0 reading. That distance from A to B you have to count it as L. That is the balancing length of this meter bridge. What is the principle of meter bridge? The principle of meter bridge is the principle of Wheatstone's bridge itself. What is the condition of Wheatstone's bridge? That means Ig current is 0. When the balancing condition is there, means what is the balancing condition? Ig current is 0. No current is being flowing through the galvanometer. So we have to find out the length at which galvanometer current becomes 0. After finding out the value of L, we can substitute that L instead of P and the remaining value of distance as the value of Q. Then after that we will get the value of unknown resistance. Yes. Thank you students.